Welcome back to Global Impacts of Fashion Merchandising and week two, planetary boundaries. If we go back and have a look at week one, remember I presented to you um, the idea that you, in particular, are a people of two worlds because you're born into a world which is in great transition and probably one of the greatest transitions in human history. So we go from a what I call the 17th to 20th century model based around the Industrial Revolution and this linear approach to problem solving. Um, and that seems to be fraying or coming to an end, or certainly under stress. And we're evolving into a 21st century world, which is uh, seems to be full of a lot of problems and therefore requires a different mindset to solve those problems. One that I suggest is needs to be holistic in its approach. One, and also one in which thrives, if you like, or certainly survives with uncertainty rather than fearing uncertainty. So within that context, this idea that you as an individual, but also brands, need to um, reconsider how they approach their everyday operations. The context in which that occurs in then, or the three main problems that I've identified we looked at last week, we said population was one of them, and the problem there was the human population is growing by 80 million people per year and will do so until the end of this century. That has the requisite problems with resource requirements to feed and house those people and clothe those people. We have a world divided between those with enormous material wealth and comfort, which is a minority of the world, about 1 billion people. We said it was Western Europe, North America, Australia and such, and the majority of the world, 6 billion people or so, 6.5 billion people, who do not have as much either money or opportunities than the developed world has. And then finally, we said that the third aspect we need to consider is this economic development model, which is at the moment has evolved into a values-based system of affluence. So material comfort is the aspiration. Having a nice house or having a big house is the dream. Having a car or two cars is part of that dream. And this all stems from the United States' aspirational model of living and its post-World War II structures that are put in place to encourage globalization and free trade to do it. And whilst it gives us or gave some people in the world an incredibly comfortable lifestyle, once again, it's unsustainable because of the resource requirements to keep everyone in that standard of living. So we've got these three problems. We've got a world that's changing, and now we need to ask the question why and how it's changing. So I present this as a possible wicked problem, which is where we finished last week. So let's have a look at this wicked problems. The theory of wicked problems first was articulated in 1973 by Rittel and Weber. And I mean, basically, it's got nothing to do with fashion, but what they were looking at was government housing in the United States. And there was a lot of crime associated and poverty associated with the people who lived in these government houses. And so they went in there trying to solve the problem. And what they found was they couldn't solve the problem, or as soon as they solved one aspect of the problem, another problem um, emerged. So they were consistently solving problems and finding new problems and solving those and finding new problems. So they observed this and sort of acknowledged it as being or titled it as being a wicked problem, one that can't be solved easily. And once again, like a lot of scientific theories, they sort of sit there a little bit before their time, perhaps, um, and re-emerge later on. So this theory of wicked problems has now been resurrected, if you like, in the last 5, 8 years, because we're finding that now we have a world which is very complex, which is multifaceted and has many problems. And they're going back to this theory and saying, well, okay, if perhaps we are in a world of wicked problems, and if that's the case, we need to approach solutions differently, or as I said previously, holistically up, up there. Okay. Again, this is just a little excerpt from a student that went to see Horst prior to him publishing it after a lecture. Uh, and the student said, I went to his office afterwards to ask, what can be done if we can't solve wicked problems? And he said, oh, we can solve wicked problems, he replied with his usual mirth. I solve many every day. The point is, he told me, that we can't solve them by reference to the logic inherent in the problem. Now, what does that mean? Well, let's look at it visually. It might make a bit more sense. Look at this guy here. He's obviously got a problem, and it's not just a problem, it's a wicked problem, because even though he's bailing the water out of the boat, he can't do it forever. He's going to tire at some point, and as he tires, the boat's going to sink even further and further. So yes, he's solving the problem, but it's not a permanent solution. Yet he's doing the right things. The problem is there's water in the boat. The solution is you have to get the water out of the boat. Therefore, he's solving the problem in the short term. But in the long term, I think he might have to swim. So what can you do in this case? Well, you step back, you look at the whole situation holistically, and you look at everything, not just the water in the boat. You look at the boat itself, you look at the entire ocean where he's located, you look at his body and his capacity, his limited capacity as a human to do that action for only a short period of time. And then with all of that information, you perhaps come up with a much better solution, such as Tintin did over here. So what if you turn the boat upside down? Now, remembering a boat is not designed to be flipped upside down. That wasn't the intention when the engineers created the boat. However, by turning a boat upside down, it doesn't sink. It's not comfortable to sit on, unlike this situation, but it doesn't sink. And so subsequently, the guy doesn't drown. So that's kind of an example. I don't know if that makes sense, but that's kind of an example of how you solve wicked problems holistically. Step back, look at the big picture, and think laterally to solve the problem. Equally, some fashion brands have decided to use organic cotton um, instead of cotton that uses a lot of pesticides. We'll talk about this in a couple of weeks' time. Um, and it's arguing that using organic cotton is kind of like this, it helps, but it can't be sustained in the long term. It's not enough. It needs to be a much bigger solution than that. So perhaps it's a step on the way, but not a complete solution. And while we're on these solutions, if you recall last week, I said to you that you get 45% of your grades from the final assessment. And to get a high distinction in the final assessment, you need to plot a solution that's quite clever like this one to solve the wicked problem that we present to you. So that's where I say it's kind of, this subject's about thinking, about creative ways to solve problems. Okay, if we look at it in an Australian context, this is what we call the Murray-Darling Basin in Australia. It's where the majority of the rain falls in Australia, or sorry, a significant amount of rain falls in Australia. All these rivers are interconnected and they flow in the direction of the arrow and come out in South Australia. The question is, or the problem is, in the last few years, we've seen a decline, both a change and a decline in the rainfall across eastern Australia. And the question then becomes, who gets the water? So that's posing a wicked problem because everyone's entitled to water. Everybody wants water, but who should get it? Should it be the rice farmer that produces food for people, the vegetable farmer that wants it, again, to produce food, the fruit farmer, or recreational fishing along those rivers? Should they have it to encourage tourism? Or the people of Adelaide, if you see down there, their drinking water comes from this system. Or cotton farmers in the fashion industry, and cotton is grown primarily in northern New South Wales and southern Queensland, in that area there. So not everyone can have the water. Someone has to miss out, and why the problem is wicked is because, who decides upon what value system do you choose which is the most important and the least important? These are difficult um, questions and challenges to face in a world where resources are diminishing and where the climate is changing and impacting on things like rainfall. Now, I have to sort of apologise beforehand for these slides. They're a bit wordy, but so I'll go through them quickly, but you don't have to memorise these. This is basically to give you an idea of the characteristics of wicked problems. So the first one is, so as I said, I'll go through them quickly. Wicked problems have no definitive formulation. The problem of poverty in Texas is grossly dissimilar. Texas was where Ritter did his research. The problem of poverty in Texas is grossly similar, but discreetly different from the poverty in Nairobi. So no practical characteristics describe poverty. So basically what it's saying, is every problem is unique, and different. So even though you can look at what someone else did in another part of the world to solve the problem, but you can't use that exact same solution in this part of the world. Kind of seeing that now at the moment with the COVID-19 response by different countries, and they're all slightly different. The way that South Korea responded and Japan is slightly different to Taiwan and mainland China and Australia and the United States. So they're all, well, the US isn't responding, but certainly the successful countries like the ones I've just mentioned have. And they all do it, they look at each other, they kind of do it similar but slightly different. Secondly, it's hard, maybe impossible, to measure or claim success with wicked problems because they bleed into one another, unlike the boundaries of traditional design problems that can be articulated or defined. What that means is if we give the water to the rice farmer, then the vegetable farmer goes broke. So have you solved the problem? Well, not really. You've decided to give it to one farmer at the expense of the other. So perhaps the price of rice goes down, but the price of vegetables goes up. So there's a relationship between those. Thirdly, solutions to wicked problems can be only good or bad, not true or false. There is no idealized or perfect end state to arrive at, and so approaches to wicked problems should be tractable ways to improve a situation rather than solve it. This means, and you see this sometimes with fashion brands that say they're sustainable. No such thing. No one can claim that they're sustainable. It's a pathway, it's a direction you go in. There's no perfect solution or finishing point where you say, yesterday I was not sustainable, today I am, because they're ongoing and forever changing. Fourthly, there is no template to follow when tackling a wicked problem. So traditionally, you would go get a textbook from a library or look online at a textbook, read that and say, oh, this is how you solve the problem. Wicked problems don't work that way. Textbooks are no good. They can guide you, they can assist you, but you can't get the answer from it. Although history may provide a guide, teams that approach wicked problems must literally make things up as they go along. So once again, we're in this lockdown, the world is in lockdown, and at RMIT, we're sort of trying to work our way through it. What's the best way to deliver? What's appropriate? What doesn't work? And it's a learning curve. Point 5, there is always more than one explanation for a wicked problem, with the appropriateness of the explanation depending greatly on the individual perspective of the designer. So each brand in the fashion industry can claim that they're working towards a more sustainable solution, and they can be very different. And that's okay, because as I said before, there's no one solution to being sustainable or ethical for that matter. It's just depending on where you're coming from, and I'll show you some examples a little bit later of that. 6, every wicked problem is a symptom of another problem. The interconnected quality of socioeconomic political systems illustrates how, for example, a change in education will cause new behaviour in nutrition. What does that mean? That means is a symptom of another problem. If you solve the problem of um, using a biodegradable fibre, for instance, so you've solved that problem, but that might have been a problem that presented itself in the growing of the fibre, and so you haven't solved that problem. So they all kind of connect to each other, or it displays the interconnectivity of each of those problems. 7, no mitigation strategy for a wicked problem has a definitive scientific test. Because humans invented wicked problems, science exists to understand natural phenomenon. So, if you're sick, you go to the doctor who uses science to cure you. Yeah. But with wicked problems, it's not a sickness, it's a problem that we created by, altering Earth's ecosystems, which environmental systems, I should say. Therefore, um, you don't use science to solve the problem. You use science to understand the problem, but the solution has to come out of our own individual creativity as human beings to solve these problems. Back to Tintin and turning the boat upside down. Science will just tell you the boat will float if it's upside down. Point 8, offering a solution to a wicked problem frequently is a one-shot design effort because a significant intervention changes the design space enough to minimize the ability for trial and error. So it's a one shot. So what that simply means is you might put a range together which is sustainable because it doesn't use dyes, chemical-based dyes, but it might only work for that particular range because the intervention changes the design space enough to minimize the ability for trial and error. So you won't have to do it again, or perhaps next time you'll have to do it in a slightly different way. 9, every wicked problem is unique, which is sort of what I was saying with 8. And 10, designers attempting to address a wicked problem must be fully responsible for their actions. You've got to own what you've created and the consequences of that. So as I say, that's just sort of gives you, the idea is to give you an idea of these wicked problems and what they are. But in short, they're not easy to solve. And when you do solve them, you find you create new problems, and that's normal. And that's the suggestion that some scientists are saying this century will be about. So using holistic, not partial or linear thinking to solve the problems. Innovative and flexible approaches built on action, experiment, and evaluate what you've done. So you should do this with every range you put out. Create a range, put it out there, evaluate if it's successful based on whatever parameters you've decided would constitute success. Work collaboratively across boundaries. Engage stakeholders, which may include citizens, in understanding the problems and identifying responses. So it's just not within the company, it's holistically. All of those people associated, usually within that supply chain, should be part of the solution. Develop core skills and competencies, communication, big picture thinking, influencing skills, and the ability to work cooperatively. I think that's self-explanatory. Envision and explore the future, adopt a long-term focus, understand how to change behavior, because remember, we're moving into a very different world, and we need to have different perceptions on how to solve problems. So in the case of Tintin in the boat, the behavior would be you've got to learn to sit on top of the boat now, not in the boat as of before. So, if you apply this solving of wicked problems to the COVID-19 situation of today, you'll find that the world as a whole is having real problems working together collaboratively to solve this problem. Everyone's arguing, the United States and the Chinese are arguing with each other about whose fault it was and where it came from. None of that's helpful. I mean, and not much of the world, everyone's putting up their borders, but we're not sort of, as a human race, we're not working together to solve this problem. And we'd be much more effective if we did. Okay, so if you want to do fashion, you need to know earth science. So this is the first point in which we now have to go a bit more out of our comfort zone and look at the picture holistically. So for the next 2 weeks, we're sort of moving away from fashion and going to learn a bit about the Earth's ecosystems and some of the problems associated with it, so that we can come back to fashion for the rest of the semester and try to solve those problems in the context of the Earth. Now, okay, where do we start? One of the problems with this idea of sustainability or climate change, or call it what you will, is that many people don't quite know, or no one really quite knows how the planet works. They know it's there because we stand on it, but knowing how it works is a bit of a mystery. Now I'm going to go back and show you this little YouTube clip. If I can get my thing to work. Have a look at this. Imagine I've got to have a look at this engine, how a car engine works. Oh, excuse me. Remember, we're looking at things holistically, because you might be saying, well, what's this got to do with fashion? As we look at this engine, we find, as it's being assembled now, we find it's made up of a lot of components. Every component is individual. There's some pistons, valves, springs, some rods, some sprockets there, nuts, bolts. And when it starts moving, we find that each component has a role to play. They each do a certain thing, and it's a bit like a musical symphony. It's all is coordinated and works together. Now, much like a symphony, what happens if we take a component out, a spring perhaps? It still works, but not as effectively or as efficiently as before. And if we take another component out, or if the chain breaks or is removed or frays, then the engine starts to change to splutter. It's still an engine, but not working as efficiently as before. So obviously, if we want to ensure, if we need this engine to get us from A to B, then we want to make sure it works efficiently. Equally, if we need the Earth to sustain us, we need to make sure it works efficiently. And the one thing that all human beings on Earth have is that we all share the same planet. We all have to ensure that it does sustain us. But to do that, we have to understand how the Earth works. And on that point, I'll just show you another clip now. This goes from Julia Roberts, and this is a bit of a reminder that the Earth doesn't need us, but we need the Earth. So the Earth has no problem changing its climate, altering its rainfall patterns, because it's still the Earth, it still spins around the sun, but it affects our capacity to live on this Earth. So have a look at Julia.
Some call me nature. Others call me Mother Nature. I've been here for over 4.5 billion years. 22,500 times longer than you. I don't really need people, but people need me. Yes, your future depends on me. When I thrive, you thrive. When I falter, you falter. Or worse. But I've been here for eons. I have fed species greater than you, and I have starved species greater than you. My oceans, my soil, my flowing streams, my forests, they all can take you or leave you. How you choose to live each day, whether you regard or disregard me, doesn't really matter to me, one way or the other. Your actions will determine your fate, not mine. I am nature. I will go on. I am prepared to evolve. Are you?
So there's a series of those videos if you want to watch the other ones. Um, but it's interesting because once again, it's asking us to change our perspective of Earth because up until now, we either perceive Earth as being a resource that we take things from to do whatever we want to, or it's just a big rock that we sit on, as I said before. But we've never perhaps seen the Earth as a living organism, which is one we'll look at a bit later on, but it was one articulated by James Lovelock, a NASA scientist, in the Gaia theory, where he said you've got to look at the Earth as a living organism in its entirety, a bit like an engine. So once again, it's about being holistic in your approach. So we're looking at this Earth and we're asking ourselves, well, how do we know if something's wrong with the Earth? You know, I look out my window and it looks like a beautiful day, so everything's perfect. How is one to know? And what we need to look at is tipping points. So I'm going to show you here. Let's say we've got, this is an image here of Western China, where the Chinese are having problem with the desert because the desert is growing and it's blowing sands onto, as you can see there, the nice green agricultural fields. So the people of China, or the Chinese farmers, are losing farmland to the desert and therefore losing the capacity to grow food. So we have in this image two systems. If you look at this yellow line here, we've got a desert and we've got farmland. And this red ball, if we look at this red ball and we see the movements of it, that represents slight variations to the farmland. And it means that one day maybe it's wet and raining, another day it might be cold, hot and sunny. But in either situation, it's still farmland. It's just a sunny day or a wet day or a windy day, but it's farmland. But we look at those conditions, rain, sunshine, wind, etc., and many others, and determine it's a farm or it's farmland. However, when some of those conditions change to such a degree that it alters that green farming land, then we can say it's tipped over into a new state. And it's, as this red ball's about to do, bang, it is now becomes a desert because whatever it is that constitutes a desert, how many grams of sand per square meter or whatever it happens to be, defines that state. So what scientists are trying to do now is decide, well, what is a tipping point? What is farmland? And what is a desert? And where's the point in between? And they're starting to measure those. So I'll show you some examples of tipping points. And so we, as in the fashion community, also have to look at those tipping points and make sure that whatever we do in our industry doesn't contribute to this red ball shifting over into another stable state. Oops, I don't know why that one's there. So one scientist who's doing that in Sweden is Johan Rockström and his associates, one of whom is here uh, in Canberra at ANU. And they've been working on a system to measure and understand how the Earth works. And they've come up with what they call the planetary boundaries, which is based on 9 Earth systems. So they're saying we should look at the Earth from a climate change perspective, novel entities, stratospheric ozone depletion, atmospheric loading, etc., all the way through. And we're going to go through those in the next 2 weeks because this is going to be the, if you like, the framework in which we decide if we're going to create a garment, are we going to damage or alter any one of these Earth systems? And if so, then we perhaps will make a different decision as to what garment we create. So the way he set it up is simply like a traffic light. Rockstrom has said a system is either beyond the zone of uncertainty, so it's at high risk if it's in the red zone. If it's in the yellow, it's in the zone of uncertainty, so it perhaps is changing from farmland into a desert, but it's still farmland. And green is safe, so it's still deemed as farmland. And then the grey ones are boundaries which have not yet been quantified. As I said, this is a theory in work in process at the moment. So the Gobi Desert in Western China is seen in the yellow zone. It's a zone of uncertainty. The Chinese are doing a lot to try to stop the desert, but as you can see by planting trees and such, um, and having some success at doing so, but it is looking like tipping over into the red zone. So this week we're going to focus on a few of them, and then next week we'll finish the rest. The first one we need to look at is climate change, the one that you hear about the most, but not necessarily the most problematic one, even though it makes the news more than the others. Okay, climate change simply means changing weather patterns. So if in the past we had predictability when it was going to rain and when the sun was going to shine, the scientists are suggesting we're going to have less certainty with those patterns going forward. And as you can see here, it's sitting in the yellow zone, creeping up. So what is climate change? Just if you don't know, we'll just go through it. This is a pattern reading left to right. Solar radiation enters the Earth's atmosphere, warming the planet, and that keeps us warm. Some of the heat is reflected back into outer space, especially because of the large white areas such as the polar caps on the north and south pole of the Earth act as, if you like, a heat shield and reflect, or like a big hat, if you like, and it reflects the sun or the radiation back out into space. A layer of carbon, I forgot it, where's the next one? Oh, yeah. A layer of carbon, methane and nitrous oxide that surrounds the planet inhibits the ability for some of the heat to escape. So it stays inside the Earth's atmosphere. It's a bit like if you keep the windows in a car wound up on a really hot day and then you go to get into that car, it's incredibly hot because the radiation can't get out of the car. Gets in through the glass, but can't get out. Thus, a general warming of the Earth's atmosphere occurs, making it habitable for humans. So this is a natural process that allows us to live on this Earth comfortably. The problem is, if you recall our economic development model, and this image here before the 1750s, before industrialization, we might have had an Earth that had people and cows and trees and such, and the radiation is coming in. It goes through that thin layer of carbon that's in the atmosphere, methane and nitrous oxide. Some of it stays on Earth, warms the planet, and some of it, as you represented by those yellow arrows, lines and arrows, goes back out into outer space. That was the agricultural stage and pre-agricultural stages of economic development. When in the 1750s the economy shifted, firstly in the United Kingdom and then to other parts of the world, shifted to an industrial model, we changed the way we related to the Earth. We improved our standard of living, but what we also did is create a thicker layer of carbon in the atmosphere, more pollution basically. And the result of that is that the radiation can't get out. So here's one of the classic wicked problems. We've got a much better, much higher standard of living on Earth, but we've changed the Earth's ecological systems and it's warming up the atmosphere. So how do you solve that problem? Do we go back to, being farmers? Is that practical or realistic? Or do we try to find some other solution to it? How did that carbon arise? Basically, the burning of fossil fuels, burning of coal, wood, oil, and gas released carbon and methane. So coal was the driver of the Industrial Revolution in the United Kingdom in the 1800s, as it was in the United States in the 1900s, as it is today in China, where they have a significant number of coal-fired power stations, as does Australia as well, as we'll see in the tutorials with that. So the effects of climate change then is heat absorbed by the oceans as well as the air. And what that does, when you boil water, you'll notice it boils over the pot. Same thing with the oceans. As they absorb heat, they rise, they increase, expand. And so you're starting to see sea level rises occur around the world. One of the tipping points is probably some of the Pacific Islands, which won't exist by the end of this century. So there's people who live there that will need to go live somewhere else. And they're currently in negotiation, predominantly with New Zealand, as to, taking on all of these people. The other effect, and this is a bit more worrying, is the ice cap melt, making the Earth less likely to reflect solar radiation. That's what we call negative feedback. So I'll show you on the next one. I might come back. So as I said, the radiation hits the Earth's atmosphere. It starts to melt the ice caps, North and South Pole, and the next season, because the ice cap is now smaller, the next season it can't reflect as much back into the atmosphere. So that actually speeds up the process of heating. And every year it's getting more and more dramatic. So it's why we call it a negative feedback effect. And the problem there is, and this is why scientists are predominantly focused on Antarctica and to a less extent on the North Pole, is that's going to be the big indicator of what happens, because they don't know when it tips over how much ice has to melt before there's a dramatic change in the Earth's temperature. And as I said before, weather patterns change. So the tipping point is the destruction of carbon sinks and the ice cap melting. And so we'll have a look at these carbon sinks, because it's a funny term. But this is a carbon sink, not the Dyson vacuum cleaner, but the tree. A tree is a carbon sink because it absorbs carbon. So if you've got carbon in the atmosphere, which is released by burning coal and fossil fuels, and you plant a tree, then that tree, for it to grow, that tree has to draw carbon out of the atmosphere, and it stores it in a tree, so very harmless. So the logical solution is, if we plant more trees, we capture and suck more carbon out of the atmosphere. The problem is, and again, we'll do this in the tutorials, that the human race is doing the opposite. We're actually cutting down trees rather than planting more trees. So we're again accelerating the problem rather than solve it. The reason for the Dyson vacuum cleaner is just to suggest that a tree is like a vacuum cleaner. It sucks carbon out of the atmosphere and stores it. If we look at Kering, which is a brand you probably haven't heard of, but you will know who they own, and have a look at, once again, the language of this brand. Where are we? Kering. Yeah, I'll accept the cookies. What's the Kering group? It's the new one. Oh, I'll do it here. Kering has announced today that the entire group will become carbon neutral within its own operations and across the entire supply chain. As a next step in its long-term commitment of sustainability, Kering will offset the group's annual greenhouse gas emissions, these are carbon emissions, from 2018 on top of all efforts to first avoid and then reduce them. So it will become carbon neutral. So this is a brand that's saying, for every ounce of carbon we release into the atmosphere, we will somehow draw it back down, so that we as a group will not contribute to climate change or carbon emissions. And why this is influential and why I showed you this, apart from, wow, look at the share price, 491 euros. The group consists of, where are they? Now I have to find the brands. Oh, here we go. The group consists of Gucci, Saint Laurent, Balenciaga, Bottega Veneta, Alexander McQueen. I think you've heard of some of these brands. So this is, you know, one of the biggest groups, one of the most influential in the fashion industry. And so what it does uh, will filter down to the rest of the fashion industry. If we look at Gucci's head fashion designer, what he announced in March or May this year is the end of Fashion Week and the end of seasonal ranges. May of this year. Where is it? So Alessandro Michel is the chief designer, declared that Fashion Week calendar is obsolete. Michel said he was no longer adhering to a rota staked out by spring, summer, autumn, winter cruise and pre-fall shows. And he says, and this is interesting, remember the concept of the traditional world and we're moving into a new world? I think these are stale and underfed words. So this is the 20th century fashion industry to have fashion shows. Clothes should have a longer life than that which these words attribute to them. So here's the head of Gucci, one of the most influential fashion brands, luxury brands, saying maybe we should start making clothes based on the quality and longevity of their lives, not fast fashion. So it's certainly an affront to the Zara model of disposable fashion. Is this the future? We don't know. But as I say, we keep looking at what the industry is doing. We keep trying to identify those players that are perhaps exploring ways to solve these wicked problems. I have to interrupt myself and mention this one because I forgot to put it in before. If we go to the Qantas Future Planet website, and we'll assume Qantas is flying planes, which they're not obviously at the moment, but let's say I wanted to go from Melbourne to, let's go Hong Kong, and I have one passenger, and I add the flight. What I get is, I don't know if you can see down here, Melbourne to Hong Kong, I am going to emit half a ton of carbon, 0.568 tons of carbon. And so what Qantas have said is, well, that amount of pollution, if you like, is going to cost $7.50. And so what I can do then is add that $7.50 to the price of my air ticket. Qantas will take that $7.50 and invest in things such as a tree, as I said before, by offsetting. That's what's meant by offsetting the carbon emissions. I created the emissions by wanting to fly to Hong Kong. They encourage tree planting and preservation of forests, and as such, as the tree grows, it draws back down that 0.568 tons of carbon that I produced in there. So this is an example of what some companies are doing around the world, is sort of a direct relationship with the emissions that they produce and how they then compensate for those emissions. Been around for a while. It's kind of hasn't taken off as successfully as one would have thought. There's a little video on it too you can watch if you want to better understand it. Um, Part of that has to do with consumer education. You know, if you present this offset flights and an extra charge of $7.50 to a passenger, and you don't explain clearly what it is, the passenger's just going to see that as an extra cost. And particularly if it's optional, they'll say, well, why should I pay it? And they won't pay it. So, I mean, Qantas can go two ways. They can either incorporate the 750 into the price of the ticket and not tell the customer, and that's kind of the H&M model, or equally, they make a point of educating their consumers about carbon emissions and carbon offsets. So that's a whole advertising and educational campaign or societal campaign that the brand needs to go down. So these are all options that different brands can take. But certainly, as I said, this has been around for a while, but in the fashion industry, certainly what's happening is they're moving in the direction of educating consumers as to the consequence of owning, washing and cleaning, and then disposing of clothes. So that may be the direction. We'll wait and see. Right, number two, how are we going for time? Ooh, ocean acidification, the change in the level of acidity. So if we look at this one, this is still in the green zone, and it just simply means how acidic it is. So it's a bit like how much vinegar there is in the ocean. Why is there acidity in the ocean? CO2, we said in the previous slides, is emitted into the atmosphere through natural and human means, through burning coal and fossil fuels. It floats up there. Some 25 to 50% is absorbed by the ocean because those things that are floating do this. They just fall back in. So we push it out into the atmosphere. Why aren't these ones falling? Come on. Oh, there we go. They don't want to fall. They want to stay there. That's right, because some do stay in the atmosphere, trapping in the heat, and some falls into the ocean. So this is another effect of releasing more carbon into the atmosphere. Chemical reaction of mixing water and carbon dioxide creates acid. And the question is, so what? What's the big deal about having a more acidic ocean? There's a problem for crustaceans, prawns, crabs, and etc. These animals can't form hard shells if you've got an acidic ocean. And as a result of that, they don't get to grow up to be big prawns and big crabs. Consequence of that is if all of the crustaceans are smaller, then the whole food chain starts to get smaller because the bigger fish are eating these smaller ones, which each year are getting smaller, means the fish don't grow to be bigger. And so you get this reduction occurring all the way across the food chain. Seagrasses will also increase in size and coverage. This is both a positive and a negative. As we know, the Japanese harvest and use a lot of seagrasses or seaweed, and certainly some scientists are suggesting that may be one of the key food sources for the human race this century is seagrasses. One, because there's a lot of it, and secondly, harvesting will not damage the ecosystem of the ocean, or perhaps not damage it. We still don't know at this stage. From an Australian perspective, some coral reefs are weakened due to low calcium in the water, and phytoplankton might be impacted. And the problem is specifically impacts on the coral reef in Queensland, which they're now suggesting will be dead in the next 20 to 30 years unless something is done about it. So, and think of that from a tourism point of view, it's a significant part of the Queensland economy. And if you lose that, well, you obviously lose a lot of the tourism that goes with that. Phytoplankton provides up to 50% of the oxygen on Earth and forms the basis of the ocean food chain up to fish and marine mammals. So often it's a bit like bees. I don't know if you know with bees, but there's a problem with bees being dying due to illness around the world, and it's causing a lack of pollination, therefore a lack of fruit being produced or grown around the world. So sometimes some scientists are suggesting that it's in the smallest organisms on Earth that will have the greatest impact on our ecosystems. And so we shouldn't ignore the big picture. We as humans tend to focus on the polar bears or larger things that we can understand and visually see, but it may actually be the smaller ones that cause problems for us. So the tipping point that scientists look for this one is biodiversity in the ocean. What's in the ocean at the moment, we watch to see if it gets smaller and smaller and smaller or changes in any way and measure that as a tipping point. And once again, as I suggested before, this is a report looking at what's been happening to corals, finfish, crustaceans, etc. And what this report is saying is, again, they're all sort of in decline, and this is a worrying trend, given that we consume a significant amount of food that is sourced from the ocean. And obviously, what all this translates to for us is that if we don't have this food chain down the bottom, we can't have a nice meal like that one there. Okay, if we look at fish harvesting, we'll just keep on oceans for a little bit longer. The wild capture is, wild fish in the ocean. As you can see, by the late 80s, early 90s, that had almost plateaued out. So um, they're not getting more fish from the ocean anymore simply because there aren't more fish to catch because we've sort of harvested a significant portion of uh, the world's fish stocks. So they're kind of, some argue they're in decline now. It's a bit uncertain, but it's certainly looking that way. What replaces it is aquaculture production. So if you source um, tuna, um, if you purchase uh, uh, tuna or salmon I was thinking, from the supermarket, it doesn't come from the ocean, it comes from a farm. And that has other food consequences which we need to consider. Although there are some positives. The one I was going to mention is creating fabric out of fish skins, which is done at the moment now. So if we see an increase in the production of fish from fish farms, perhaps we as a fashion industry should start considering whether we want to make our clothes out of fish skin. Hopefully they wash it first because it would be a bit smelly. Third one is biosphere integrity, and big word, but as you can see here, the suggestion is that it is in the red zone. It is beyond the zone of uncertainty or at high risk. So biodiversity is simply the variety of plant and animal life in the world in a particular habitat, a high level of which is usually considered to be important and desirable. So it's about the number of species in and on the earth. Why is it important to have a variation of species on the earth? It's because of this image here. If you have a look at this alligator, you'll notice he's got a little bird sitting in his mouth. And these two creatures have a special arrangement. After the alligator has finished eating his lunch, he's got a deal with the bird where the bird comes along and will pick, like a toothpick, will come along and pick all the meat in between his teeth, although it doesn't look like there's much meat there, to clean his teeth. The result of that is the bird gets fed and the alligator has nice shiny teeth. You remove the bird from that species, or you remove either of them from that ecosystem, and they will then have to adapt to a new arrangement. Who's going to clean the alligator's teeth? Probably no one, and as a result of that, the alligator's teeth may get infected and he'll eventually die of blood poisoning. And then vice versa, the bird needs to find some other source of it. So there's a real importance in keeping as many species on Earth as possible to ensure that you have these relationships, some of which we understand, like this one's quite straightforward, and some which are much more complex and obscure, but equally important. So one of the problems is they don't know how many species there are on Earth. There's something they suggest it's up to 8 million species that interact with each other, but no one knows for certain because we're still discovering new species. If we have a look at this table here, what this represents is what scientists have defined as the 5 extinction phases in the past, with the fourth one you'd probably be familiar with as the Jurassic period. The fifth one was when the meteor storm hit and killed most life on Earth, is the suggestion, 75% of life on Earth. We are now in what scientists say is the 6th mass extinction phase because the rate of extinction of species on Earth is as great as it has been during that KT mass extinction phase, phase 5. The only difference with this one, if you have a look down the bottom where it says suspected cause, each one had to do with volcanic activity or, as I said, impact from objects from outer space. The 6th one, this one that we're currently in, is caused by the activities of one species alone, and that is humans. So the actions of humans is causing the extinction of many species on Earth. And once again, if I go back to this concept of biodiversity is integral to a healthy planet because of the relationship that occurs. If you start pulling these pieces out, we may find, as some scientists suggest, a dramatic spiral down in the quality of life on Earth for all of us. And as it was created by us, as I suggested last week in the age of the Anthropocene, we also have the capacity to stop this extinction by changing our activities on this Earth. And so that's, to some extent, what's shaping up to be the theme for this century, is how we relate to the Earth and all the other creatures on this planet. So the biosphere integrity, the effects are, as I said, that we're in the sixth great extinction phase. So things like deforestation, cutting down trees to grow crops because we need to eat food is part of that extinction phase. Changing the ecosystems, the weather systems, and how warm or cold it is in certain parts of the world. That's one point I didn't mention before. Um, Climate change doesn't mean that the whole world gets hotter. It means the climate changes. So some parts are actually going to get colder. Some parts are going to get wetter. So around the equator, for instance, the rainfall is going to increase. And where we are here in Melbourne, Australia, scientists suggest it's going to get drier. So it depends where you are. Damming of rivers, harvesting of oceans, all of this detracts from the quantity of life on Earth. And the tipping points, as I said, we don't know because we don't know how many species there are. We don't have a full account of all the species, but we do have some. And again, we'll look at the United Nations Red Book in the tutorials to have a look at that one. But obviously, if we don't know what we're measuring, we don't know what we've lost. And that's why this one is one of the more worrying ones. It doesn't get as much media attention, but it's certainly as concerning as climate change is. Number 4, freshwater use. This one sits in, we're almost there. This one sits in the green zone for a particular reason. I mean, you'd think we'd be running out of water, but not quite. Why it's of concern to us is for this crop, cotton. The fashion industry uses a significant amount of cotton. Cotton uses a lot of water. Therefore, it's right in our line of sight as to whether we should or shouldn't use cotton in the future for our garments. But let's have a look at fresh water first. Fresh water, we probably think of fresh water in such a glass as in a glass of water. But that's only one form. This water can also be in the fridge in an ice cube. It can be underground in an aquifer. It could be in a cloud as well. So water is on Earth in different forms, shapes and forms. It's in our bodies all the time as well. So the problem isn't the amount of water, the problem is where the water is. Because it could, as I said, it could be in the clouds, but the clouds don't drop their rain, so we can't access it very easily. If we look at this model, then we get transpiration from plants, which is a bit like sweating, if you like, from plants that condenses and forms clouds. Clouds float around the earth until they get too heavy and they drop their water. Rains, goes into a river, into a lake, and some of it goes underground, some of it goes into the ocean, and the cycle repeats and repeats. Where are we? We all want and need water. So if fresh water is removed at a rate greater than it can be replenished, then shortages occur. So if I go back to this little image, if we're all taking water out of that river at a rate greater than the ice can melt, well, obviously there won't be any water in the river. So it's the rate of extraction of water that is problematic. And we need it, obviously, to keep clean, to drink, to cook, food production, and in the fashion industry's case, as I said before, cotton, but also the dyeing industry. And we're going to look at these in a lot more detail going forward. Tipping points are easier to measure on this one. We just measure how much water is underground in the reservoirs and changing rainfall patterns. If we look at Melbourne's, come on, where are we? Water storage, just to give you an example. Why it's easy to measure this is because, here we go, this is as of today. Um, the water storage in Melbourne is at 64.5%. So it's actually a little bit low for winter, because remember, we've got next month is the last month of winter with the highest rainfall. But we obviously track that, and you see the sophisticated figures as to which reservoir around Melbourne has rain and has water, excuse me, and how much water they've got as well. So this is kind of a good example of being able to measure a tipping point easily. And then for us as a fashion brand to say, yes, we want to grow cotton in and around Victoria, or use water from around Victoria to grow cotton, because we can obviously see there's plenty of water or there isn't plenty of water, unlike biodiversity, which is a lot more difficult to measure. Okay, in summary then, um, I started off with a wicked problem and saying we have to look holistically at a problem to solve it. So you've got to think outside the box, if you like, to solve that problem. But to do that, you've got to understand the whole, everything that impacts on that particular situation, not just, tunnel vision. When we look at the Earth's ecosystems, what we're looking at is tipping points, the point at which our actions are going to tip a system into something else. And so the desert farmland one was an example of a natural change in an ecosystem, but many of the changes are human induced. And thirdly, we then looked at Johann Rockström's planetary boundaries and the 9 Earth systems, which is kind of like a checklist for us to sort of tick against and say, well, this range does not impact on climate change. This range does not impact on freshwater use in this part of the world, etc. Or it does. So it allows us to sort of alter that. So we just looked at 4 today, and next week we'll look at the rest of them. So we have a sort of a good understanding of the Earth systems and how our brand will impact on it. Thank you. I hope you found it informative and enjoyable, and I'll see you in the tutorials or next week. Thanks.